Okay. Next is the paper insulated cables. So, diagram and other thing cables, I will come to that, I will show you from the book only, but later. So, paper is most important insulating material used in the manufacture of power cables up to 500 kV rating, right. So, these paper insulated cables are very common. So, the paper insulation has the advantages of superior heat conductivity, then ability to withstand high temperature, then durability, then high dielectric strength, low cost and low electrostatic capacitance. So, these are the your advantages for paper insulation, right. And for providing insulation over the conductor, the paper tape is lapped onto the conductor until required thickness is obtained. So, it is then dried and impregnated with insulating compound, right. So, it is when cable when manufacturing process is not easy for cable, that is why cable is very expensive, right. So, that is that your what you call that paper insulation. So, repeat again that superior heat conductivity, then ability to withstand high temperature, durability, high dielectric strength, low cost and low electrostatic capacitance. Right. The insulating compounds are required to have high insulation properties, then a high viscosity at working temperature, say 50 to 80 degrees Celsius normal, a low viscosity at impregnation temperatures, that is 105 to 120 degrees Celsius, a smooth change in viscosity with temperature, and very low coefficient of thermal expansion. So, these are the insulating compounds are required to have, right, particularly the very low coefficient of thermal expansion. The insulating compounds are all based on a paraffinic or on a your naphthenic mineral oil, right. Resin being often added to improve the impregnating quality, since it is important that no air void should be left in the finished cable. I mean, when cable is manufactured, there should not be any void, right. No, there should not be any void, then it will create problem. So, there should not be anything, right. So, the impregnation of your paper insulation increases its dielectric strength from about 3 to 5 to 10 to 8 kilovolt per millimeter. That means, that is the advantage, right. If that is from 3 to 5, instead of about 3 to 5 to 10 to 80 your kilovolt per millimeter. The dielectric constant of impregnated paper insulation is about 3.6 roughly. Another thing is the thickness of insulation depends on the mechanical and electrical requirements which it has to withstand in service. It depends on the voltage level, right. Thickly depends on the mechanical and electrical requirements. So, which has to withstand in service, it depends on the voltage level, how you are doing single core or 3 core or say, right. So, the low voltage cables, that is less than 1 kV rating, should have sufficient insulation thickness to meet the mechanical treatment which the cable may undergo during manufacture, installation and service. So, these are certain things, right. At higher voltages, the insulation thickness is determined by electrical requirements, particularly the voltage level. Next one is diagram, I will come later, Next is sheath, armor and covering. So, generally a metal sheath is provided over the cable insulation, so that moisture may not be able to affect the insulation and may also protect the insulation from mechanical damage. That is why a metal sheath is provided, right, over the cable insulation. First conductor insulation and then metal sheath is provided. What metal sheath is, we will see later, right. Also to protect the insulation from mechanical damage. A metal is essential for sheath because no organic material is sufficiently impervious to moisture. Lead was established as a suitable material for sheathing, but later we will see that lead has very high specific gravity as compared to your aluminum, right. So, the main advantage of lead sheath are the comparative easy with which they are made in lead presses. Second thing, their flexibility and high corrosion resistance. These are the advantages, but disadvantages: large mass, because specific gravity of lead is 11.37, low mechanical strength, and fluidity and small resistance to vibration. These are the disadvantages of lead. The hardness, mechanical strength and resistance to vibration of lead sheath can be considerably increased by adding alloying mixture. I mean, some kind of, you have to mix copper, tin or bismuth, right. Then this mechanical strength and resistance to vibration of lead sheath can be considerably increased. That means, many alloys of lead having about 1% of copper or tin or bismuth can be used for sheathing, but aluminum is now being increasingly used as a sheathing material. Aluminum sheaths have a much greater mechanical strength than lead sheath. Low weight, specific gravity is only 2.71, so roughly your 1/5 of your lead, and low fluidity. The aluminum sheaths cost about 3.5 times less than lead sheaths. Cost is also lower for aluminum, right. So, I mean, for cable several components are there, one after another, right. Diagram I will show you how things are. So, steel tape or wire armor is necessary to protect the sheath against mechanical damage. Look, we are protecting insulation for the sheath. Now, steel tape or wire armor is necessary to protect the sheath against mechanical damage. That means, another round you have to use for steel tape or wire, one after another. So, steel tape, it is like your, to some, it is like onion, no, one after another you are this thing. So, steel tape armor consists of two steel tape coated with your preservative compound, applied helically in the same direction over a fibrous bedding, the outer layer covering the spaces between turns of the inner layer. This provides a good protection against mechanical damage, but steel wire armor is recommended where additional longitudinal traces may occur during installation or in service, right. So, initially if I show you the figure, then it is not possible to tell all these things. So, steel wire armor consists of a galvanized steel wires applied over a compound bedding. Now, double wire armors are used for a high degree of mechanical protection, but cost will increase. Single core cables for AC system are usually not provided with armor because of its effect in increasing the losses, because loss will be more. Later we will come to all these things. In these cables, a plastic or PVC oversheath is used for mechanical protection. So, as an anti-corrosion measure, power cables are usually protected by bitumen impregnated fibrous wrapping or covering or serving. So, these are certain things, but next is that generally two layers of such coverings are provided, one layer over the sheath and then on the inner side of armor and the second layer over the armor. Now, before classification to your this thing cable, right. So, first I will show you one diagram and then this thing. Generally do not see anything. So, these are, here is standard conductors, these are, I hope it will be readable for you. These are the core, the conductors, and after this the insulation is there, then next is metallic sheath is there, because you have to cover the insulation by metallic sheath, and then after this the plastic oversheath is also there. So, if you look at this diagram, particularly look at this diagram, right. Of course, this is your oil duct cable, that does not matter, forget about that. Look, after this the paper insulation is there, over insulation lead sheath is there, and after that the rubber is also there, right here, and this is conductor. Here carbon black and metallized paper is also here, then compounded cotton tape is there, then silicon bronze reinforcement, and finally it is proofed cloth and compounded Hessian double tapes, right. Look, so many materials are there for the cable. This is later we will come to that, your oil duct or your oil field or gas field cables, but this is actually so many coatings are there, different for your what you call that different type of cables, right. So, some kinds your flat type, sometimes all the things, all the 3 cores, that they will be binded together also, right, by different your material, that will come later. So, classification of cables. So, paper insulated metal sheath power cables can be classified as solid and pressurized cables. First is solid type cables. In these cables, the pressure within the cables does not go above atmospheric pressure and may even fall below it locally. Example, in voids, if void formation is there, then it will be less than that atmospheric pressure. This can lead to cable breakdown. Here I have written here, it will lead to cable breakdown when the electrostatic stress is high. The cables for voltage up to 33 kV belongs to this category. So, solid type cables is used for up to 33 kV, right. Next one is that pressurized cables. In this cable, pressure is maintained above atmospheric, either by oil in oil filled cables or by gas in gas pressure cables. I just show you one diagram, that oil filled one. The gas pressure cables are used up to 275 kV, while oil filled covers are used up to 500 kV or so. So, now this one, either of these may be single core or multi core, either single core cable or multi core cable, right. So, a solid single core cable has a central conductor with an insulation of impregnated paper, a metallic sheath and a plastic over sheath. That is the figure 1 shows this. This is your core, that conductor is there. Then you have the insulation, over insulation metallic sheath is there, and then your plastic over sheath is also there. This is single core cable, right. So, this diagram I have taken from a book. Next is that this is belted cables, 3 core and 4 core. I will come to that. So, a multi core cable may have 3 cores, that is for 3 phase 3 wire system, or 4 cores, that is 3 phase 4 wire systems, and maybe a belted type cable, right. So, a belted cable has a part of the insulation applied to each core individually and the remainder in the form of an overall belt as shown in figure 2 and below. Here this is, so many things are there. This is actually, if you look into this, this one, your what you call, this is the core, that conductor, inside that insulation is there, and then belt insulation is also there around this one, around all these things, that individual insulation between the cores, then around that all these cores you have the insulation. Then you have the thickness of insulation, which is conductor and sheath. This is the thickness of insulation between conductor and sheath, right. Next is thickness of insulation between conductors. So, this is the conductor, this is the conductors, in between the thickness of insulation between conductor, the insulation is there. Then if you look into this one, core insulation, here you look around the core insulation is there. Then belt insulation I told you around this, then armor is there, armor ring is there, and the wrapping, here it is one, another is one. So, wrapping is there. This is actually 3 wire, your for 3 phase 3 wire system, this is 3 core cables. Here it is conductors actually, the way it is shown. Next is 3 core, this is 4 core. So, there are 4 cores and philosophy remains same. All the things whatever I said, same thing is here. So, just see, so many things are wrapped on the conductors, insulation, then your what you call armor, then core insulation is required, then your what you call insulation between conductor and sheath is required. So, everything is required to manufacture the cable. So, it is your what you call, this is 4 core cables, right. So, this is a belted cable, because all are together, right, in the same thing. So, this is actually a belted cable, has a part of the insulation applied to each core individually, and the remainder is the form an overall belt as shown in your figure 2a and b together, right. This part initially little bit of theory, and after that all these things will come, mathematics part. So, the cable is provided with a metallic sheath and anti-corrosion serving and armor, and a second layer of anti-corrosion serving. Belted cables are used up to 11 kV, right. Next is pressurized cables. solid type cables are suitable only up to 33 kV. At higher voltages, the chances of breakdown in cables due to ionization in voids become quite high, right. There is a possibility that breakdown due to that your ionization in void. In pressurized cables, voids are eliminated by maintaining a higher pressure than atmosphere, right. So, pressurized cables are either oil filled cables or gas pressure cables, right. So, particularly for high voltages, but advantages and disadvantages are also there. For example, that oil filled cables, so single core and 3 core, this is actually oil filled cables, this diagram, it is oil filled cable, this is the oil duct, right, and if you look conductor on it, so it is actually oil duct, right. So, single core and 3 core oil filled cables are suitable for 33 kV as well as higher voltages up to 500 kV. A oil filled cable is kept constantly supplied with low viscosity mineral oil through ducts in the cable. This is the duct, and through this duct this oil, your oil flow has to be maintained. That means you have to have a reservoir for oils, right. So, constantly supplied with low viscosity mineral oil through ducts in the cable, the ducts being connected to oil reservoir, there must be oil reservoir also. The expansions and contraction merely produce changes in the oil level. So, there will be no change in the oil level in the reservoir for extension, your expansion or contraction, and therefore, do not result in void. So, there will be no void formation. Another advantage is that any space formed by the distortion of lead sheath or by relative movement of the paper dielectric is immediately filled with oil, right. So, if it is for example, lead sheet or your this thing, your paper dielectric, this is actually lead sheet is here also there, right. Then compounded cotton tape is there, then carbon black and metallized your paper is also there, it is visible, everything it is there, then paper insulation is there. So, another advantage is that any space formed by the distortion of lead sheath or by relative movement of paper dielectric is immediately filled with oil. So, there is no chance of void formation, right. Now, the breakdown inception stress for oil filled cables is 300 to 400 kV per centimeter, the quite high, which is much higher than that of a solid type cable. So, it is advantageous. Therefore, the normal operating stresses are raised considerably. The insulation thickness is mainly governed by the requirement of impulse breakdown. The insulation thickness of a solid type cable is governed by requirement of withstand of voltage at power frequency, but here the insulation thickness is mainly governed by requirement impulse breakdown, right. So, maximum traces up to 130 kV per centimeter are acceptable for 275 kV and 400 kV oil filled cables. So, maximum traces is about 130 kV by centimeter per centimeter are acceptable for 275 and 400 kV. So, here it is 300 to 400. So, quite acceptable that your maximum traces, right, particularly oil filled cables. So, next one is a single core oil filled cable has the oil duct either within the conductor, that is the conductor is hollow, or in the sheath, right. I show you the diagram. A 3 core cable has 3 oil ducts. If you have a 3 core, so 3 oil ducts will be there, one in each filter space. The pressure within the cable must not fall below atmospheric, and a lower limit of about 21.7 kilonewton per meter square gauge is set, right. So, must not fall below atmospheric pressure, and the lower limit of about this much is set, this much gauge thing, right. The transient pressure developed when the load is suddenly increased. So, naturally transient pressure will be there, should not increase beyond about 8600 kilonewton per meter square gauge, right. So, these are your what you call that you have to maintain this, for your oil filled cables. Next one is that your what you call the gas filled cables. So, in this cable the paper dielectric is impregnated with petroleum jelly. so that it may not have any free compound, right. The interstices between the layers at the paper are then filled with gas, generally dry nitrogen, at a pressure up to 1380 kilonewton per meter square, forming a composite dielectric. Pressure is retained by the lead sheath. So, this is for gas filled cable. Some advantage is there for gas filled cable. The gas flows throughout the cable via the filler spaces. You have the filler spaces, and your I do not have the diagram here for that gas filled one, but the gas flows throughout the cable via the filler spaces, butt gaps in the dielectric and conductor strands. But one advantage is there, here no reservoir is required. And if void formation is, just hold on, in single core cables a small clearances to sheath is left for allowing the axial flow of gas. So, there should be a small clearance to sheath your is left for allowing the axial flow of the gas. In case of multi-core cables, such a clearance is not necessary because the filler spaces and strands provide a sufficient low resistance path for the flow of gas. The advantage of gas filled cable over the oil filled cable is that oil pressure reservoirs and other extraneous apparatus are not necessary, right, and still the ionization is avoided because the voids are filled with gas at high pressure. So, that means if there is any void formation is there, that void will be filled by the gas at the high pressure. So, this is the advantage, and no oil reservoir is required for your what you call that gas pressure your cables, right. I have diagram is here for this thing, external gas pressure cables, here it is there. So, these are the your here from the diagram you cannot make out, but some your clearance will be there for the your gas, right, and in any void formation anywhere is there, this gas will take the place of the void at high pressure. So, there is no chance of breakdown. This is your what you call gas pressure cable, that is external gas pressure cables, right. So, different types of, I mean all the things may not be available in front of you, but certain things you have to rely on the books, right, because unless and until you go to some power plant or substation, if those cables are available you can have a look, right, on this kind of cables. Next is another cable used for high voltage is external pressure cable. In these cables the your conductor cores, after being insulated, impregnated and covered with sheath, right, are placed in a steel pipe which is filled with gas, generally nitrogen, at a pressure of about 12 to 15 atmospheric pressure, right. So, that means your external gas pressure cables, right. This is that diagram, this is the diagram for external gas pressure cable, right. So, this is also used, right, but pressure 12 to 15 atmospheric pressure you have to maintain. Because of external gas pressure, the voltage required to set up ionization inside the void is increased. Moreover, the external pressure tends to close the voids. So, there will be no question of your breakdown if void formations are there, but manufacture of such cables is very complicated one, right. But these are your some ideas about the theories. In comparison with a solid type cable, this construction gives twice the working voltage and about 1.5 times the working current, right, if you compare with a solid type of cable, but the increased cost is more than offset by the increased operating voltage and current. That means, but cost of these cables are very high, that therefore, whatever technical advantage you are getting, that will be completely offset. In addition, the steel pipe provides an ideal mechanical protection for the cable. So, this is your steel pipe, right. That means, additional cost you have to incur for, right. So, this is actually what you call whatever little bit of cables theories are there, something some demo diagram we will see later, but somehow I have to condense everything, because this I found cable is a very long chapter. So, but we have many other topics has to be covered. So, that is why, but a little bit ideas you have, and and some altogether 5 reference books will be given to you, and books and those books you please follow. Perhaps most of the thing you will get it. I'll give you 5 reference books for reading, textbook, right. Next is the effective conductor resistance of the cable. Here it is the effective resistance, it is made R effective, right. This is R effective of each conductor of a cable has to be calculated by taking into account the DC resistance. This is actually DC resistance, skin effect, then proximity effect, sheath loss and armor loss. This skin effect and proximity effect you have studied in your inductance calculation chapters, right. So all these things you have to consider for calculating the effective conductor resistance of cables, right. First one is that DC resistance, right. You come to DC resistance. So in calculating the DC resistance, the increase in resistance due to temperature effects of stranding and laying should be taken into account. You have to consider this. First one, the conductor temperature must not exceed 85 degrees Celsius for pressurized cables. For other cables, the specified temperatures vary from 50 to 75 degree Celsius. The DC resistance at the maximum temperature may be about 20% more than that of at 20 degree Celsius, right. The resistance is multiplied by 1.02, that means 2% increase to account for stranding, and in case of multi-core cables again multiplied by 1.02, that means 2% increase to account for additional length of conductor resulting from your lay of strands and of core in manufacture. So this 2% your things you have to multiply, so that more or less you will get that your what you call that more or less accurate values, right. So next is skin effect. Skin effect you have studied, so it will not be covered here, just its effect on cable it will be given. The increase in resistance due to skin effect depends mainly on the cross sectional area, that you know, right. For example, for 400 millimeter square and 600 millimeter cross sectional areas, the increase in resistance at 50 hertz is about 3.5% and 6.5% respectively, right. So this is for skin effect. Roughly using this cross sectional conductor you can try to compute it also, but in your inductance chapter you have studied skin effect. Proximity effect also, right. So the increase in resistance to non-uniformity of current density over the cross section of this of the conductor caused by magnetic field of currents between other phases, right. Phase conductors is greater in single core cables than in 3 core belted cables for a given size. So proximity effect also you have to consider. Proximity effect also you have studied in your inductance chapter in your power system analysis course in your college. So those things will be not covered here, right. Only for cable calculation purpose it has been shown. Now for 3 core belted cables, the increase in resistance due to proximity effect is about the same magnitude as that of skin effect. I mean both increase will be effect is same for proximity and your skin effect. The DC resistance at the operating temperature as modified for stranding, laying, then skin effect and proximity effect is termed as AC resistance, that is RAC, right. We refer is a RAC. So thank you, again welcome.